Good day, everyone. We are from the SMT1C Group 1. So the title for our report today is Stoichiometry and the Law of Chemical Reaction. Next,
Learning outcomes. The student should have interpreted the relationship between the amount of the reactants used and the products formed in a chemical reaction, demonstrated the laws of conservation of mass and definite proportion.
Introduction. Stoichiometry deals with the weight-to-weight relation and weight-to-volume relations in chemical reactions. It deals with the basic concept of a chemical equation, which is dependent on the idea of the chemical formula. The quantitative interpretation of the chemical formula is related to the atomic mass. Stoichiometry is the utilization of atomic masses to account for the quantity of materials observed to be consumed and produced in the chemical changes. The law of conservation of mass, the law of definite proportions, and the law of multiple proportions summarize the law of describing chemical change. In a chemical change, bonding pattern change and new substances form all chemical reactions are chemical changes. The law of conservation of matter states that matter cannot be created or destroyed. In chemical change, the total mass of the reactants always equals to the total mass of product.
So yes, we have first is 10 tube, 1 test tube rock, 1 test tube brush, 1 250 ml beaker, 1 small test tube, 1 Erlenmeyer flask with stopper, ruler, water bath, and balance.
Procedures. Stoichiometry. Label 5 clean dry test tubes from 1 to 5. Step 2. Rinse the reagent dropper with potassium iodine solution before using. Procedure 3. Place 30 drops of potassium iodine in each test tube. Procedure number 4. Rinse another reagent dropper for lead nitrate, and procedure number 5, add the following number of drops of lead nitrate to each label test tubes. Procedure number 6, place the test tube in a boiling water bath for 3 minutes. Procedure number 7, remove the test tubes from the water bath and measure the height of the precipitate formed in each test tube. Procedure number 8, plot the height in the precipitate along the coordinate and the number of drops of lead nitrate used along the abscissa.
Law of conservation of mass. First procedure, obtain a small test tube which can fit inside the Erlenmeyer flask. Next, weight the Erlenmeyer flask and test tube separately. Place the 10 ml dilute sodium chloride inside the Erlenmeyer flask and 2.5 of silver nitrate solution in a small test tube. Next, carefully insert the small test tube inside the flask. Be careful not to spill its content. Fifth procedure is seal the flask with a stopper. Measure the total weight of the setup. Slowly incline the flask until the solution inside the test tube is mixed with the solution in the flask. Seventh, take note the observed changes. And lastly, weight the mass of the setup after reaction.
Law of definite proportion. Step number 1. Obtain 5 clean dry test tubes. Number them from 1 to 5. Step number 2. Into each test tube, Place exactly 5 ml of lead nitrate. Add the following quantities of 0.5 mole copper sulfate into each test tube in consecutive order: 1 ml, 2 ml, 3 ml, 4 ml, and 5 ml. Step number 4. Set aside and allow the precipitate to settle. Number 5. Measure the height of each precipitate in each test tube. And number 6. Observe also the color of the supernatant liquid in each test tube. For our conclusion, given a chemical reaction, stoichiometry tells us what quantity of each reactant we need in order to get enough of our desired product. Because of its real-life applications in chemical engineering as well as research, stoichiometry is one of the most important and fundamental topics in chemistry.
So that's all for today. Thank you.